Thank you for joining in. This project is funded by the European Union Horizon program. Our webinar series is a part of the Circ-uits project and EU GreenWeek 2025. Please enjoy.
I'm Lisa Davel, and we are from Office, so we are a research institute from the University of Oldenburg in Germany, and it's a research institute for computer science. And today I want to present you our digital twin that we did in Circ-uits, or the design digital twin as we called it. Mattia from TXT already had a short introduction about that, but I want to start right now with challenges in green design that kind of motivates the design digital twin that we developed. And sustainability, when we want to optimize a product to be like super sustainable, it's really hard, and it's also called a wicked problem of sustainability, because as we can see here on the slide, I have this kind of spider diagram, and now I have different kind of designs here, and in gray these are my minimal requirements, so that's what I want to have at least. And then in this case, or for this presentation, I made all the KPIs so that 5 is always the best, so the more I'm outside, the better my design is in terms, for example, of CO2 score, recyclability score, repairability score. And I drew some sample designs here so that you can see, okay, there's maybe my first design, that is the one that I have already, but then I want to improve my CO2 score, and I can see, okay, in some areas I'm better as well, but in some I actually get worse. And then I do a third design that is better in those categories, but then I lose in some others as well. So it's kind of like a Rubik's Cube. I think everyone knows this kind of thing. You make one side perfect, but then all the other sides are kind of broken again. So that's why we developed the digital twin, so that you can actually see all the sides, because when you do it by hand, it's really hard to see actually this kind of overview here. And let's see, why can't I go to the next slide? There we are. Here you can see our tool architecture. So this is a long or big slide, but I don't want to go into detail for everything, but I want to show you like the overview of what we did. So in the middle we have our digital twin, and since we are in Circ-uits, it is part of the platform that Mattia from TXT explained. And one of the key inputs for our digital twin is the life cycle analysis from the Greta tool, so from Subsi, as Christian showed us before. And then we also have the recyclability assessment from Mara, so what Antoinette just showed. So these are kind of inputs for our digital twin. But then we also use the repair assessment, so here from the top, which I will show you in this presentation as well. Then here on the right side, we have a critical raw materials assessment, which shows you kind of the criticality of the materials used and gives you like an indication how long might they be available and if there's risk associated with those materials in the long term. And then of course we have the OEM data as well. So on the next slide, we can now see the digital twin here. And we made an example with coffee machines, because I think everyone knows like a drip coffee maker, where we have the components that you can see here. So we have the dripping mechanism, we have a heating element and a water reservoir, so very simple. And then we have different component versions. And on the left side, we have kind of the status quo of our coffee machine. And on the right side, we have the green design. And then we can see we have different sustainability KPIs that we get, for example, from Greta, from Maras, but also the repairability assessment that I will show you later, and then also the criticality assessment, which I will show you in the next slide. And that kind of all comes together. So this is just the overview of the different designs where you can just see what have I like kind of created or designed here. So on the next slide, we can now see the critical raw materials dashboard. On the left side, we have a lot of primary sources, but the main methodology that we are using is the EU criticality assessment. And then we have this dashboard that brings it all together, and the output is then used for this product information. So the dashboard is kind of general. So as you can see here, we have a material that we can use, for example, aluminium, and then we can select the time frame and the sources. So the critical raw materials dashboard that we used was focused in the development that you can always select the sources where the data is coming from, and you can combine them or choose different sources. And then you can see kind of where is the production coming from and where is it gonna be refined and what is the criticality. So here on the right side, we can see the world production of the primary material. And then we can see also the world production of the refined material. And then we also have that for EU in this case. And then we have EU primary and EU refined. And for example, here we can see, okay, aluminium is critical. Okay. So now we want to bring this together with the product that we want to assess, which we can see here on the next slide. So this is not based on the EU assessment, but on the Augsburg method. Yes, and we can have here, or we have here different components that we can look at and we can compare. So for example, we have two versions of our dripping mechanism for our coffee maker. And we say, okay, what is actually best in terms of criticality? And that's what we can see here. So we have a list of all the materials for this kind of component. And then we have the individual supply risk. And then we have the spider diagram to compare the kind of two components. And here you can see there's not so much difference, but in other designs, there might be a bigger difference. So now I leave the kind of area of criticality and I go now to the next assessment, which is the repairability assessment. And we carried out the repairability assessment of the kind of product design with Bosch and also with Continental together. And we found out that it's kind of hard to actually do it with the norm EN 4554. So that's why we are currently working on a CWA together with Bosch to modify the EN 4554 to be used by the manufacturer itself and how it might be used in the automotive industry. And here you can see, okay, we have this kind of component breakdown structure here on the left where we have the product, then maybe the housing, and then some subcomponents. And then you can see here, which is kind of the tool that helps you with the repairability assessment, and you get kind of repairability assessment for each component. And then it's all summed up and it's kind of like weighted sum for the whole product that you can then use in the digital twin, where everything kind of comes together with the criticality, with the LCA results from Greta, with the recyclability, and so on. And about the repairability, we not only looked at the design, so it might be an existing design, but you can also carry out this kind of assessment with a future design, as long as you have kind of a rough idea what it is. So you need to have some information, obviously. So it has to be quite concrete already if you want to do it with a future design. But then we also looked at existing products and what we can do in terms of repair. And we developed an AI-supported repair assessment. So here you can see it's kind of an electronic control unit, so ECU from a car. So this is from Bosch. And we want to see, okay, so the housing or the cover was removed. So now we look on the inside and we want to say, okay, can we actually repair it and go back and send it back to the field or not? And one of the factors is, for example, if these coils are bended too much. So this one here is kind of on the brink where you say, okay, maybe it's bended too much, or this one here as well. But this one is definitely broken. Then we can't actually repair it. So we use AI to sort out those ECUs that cannot be repaired as early as possible and send them back, and then maybe for recycling or any other way. But then use those that pass kind of the inspection to be repaired and to be sent back. And then first thing that we did is we used an object detection algorithm, which here kind of aligns the housing. Then we have the coils here that are surrounded, and then we have the plug. And there are different things that we need to check. So we need to check the coils, we need to check if the pins are still straight, and then we also have these ledgers if they still work. So for that we use the object detection algorithm. And now I go to the coils, and we want to train an algorithm to find out those that don't work or that are broken. And because in our case we had a very low sample size, we used a generative model, which we can see here on the right side, and we can see the training. And it is basically creating here this part of the coils and giving us basically new training information. So based on the samples that we have, it creates new samples that are kind of similar, but not in the same way. And you can see it here that the coils, you can already see them, but they are also kind of wonky, and that's what we actually want. So that's the next step that we did, the generative model. And then the last step is the classification algorithm. And for the broken coils, with our new data set that we created, we have an accuracy of 90%. So with 90%, we classify everything correct. And if we didn't use our generative data set here, our accuracy was below the average. So if we just roll a dice or if we flip a coin, we would be actually better than with our previous algorithm. So that's why we created this generative model. We increased our data set by a lot. And now we have a classification accuracy of 90%. So that's really good. So now on my last slide, I want to wrap up and just show some use cases from Circ-uits that use kind of the whole digital twin. So we already heard about the Bosch use case with the ECUs, where the ECUs itself have a really long lifetime due to strict safety requirements because we are in the automotive industry. And then we use the AI support for the repair assessment. And then we also, Obot wants to do a green design. We also use another use case from Circ-uits with Continental with their tire sensors, which are currently discarded with the tires. So Continental is working on the green design. And then on the right side, we also use a data set from professional data centers, where we take the old PCBs. And with those, repair is not useful because they are run until they are completely broken. But then recyclability is more important, and especially for the critical raw materials. So that's it from my side. And now I can hand back to Paulo.
Thank you for watching this webinar episode. If you're as passionate about sustainability and innovation as we are, here's how you can get involved. Stay connected with us on our social media and website for the latest updates and insights from the Circ-uits project. Whether you're an individual or an organization, there are plenty of ways to contribute. Reach out to us to learn more about partnership opportunities, events, and initiatives.